In one of India's poorest regions, young engineers proposed something that sounded completely insane: building roads from garbage. Specifically, discarded coconut husks that farmers had been burning for generations. American road builders heard about it and laughed. Roads from trash? Impossible. But what these Indian innovators discovered would force the entire world to stop laughing and start paying attention. Welcome to Macro Forge, where we explore solutions that sound too crazy to work. If engineering that turns waste into wealth fascinates you, subscribe now. What you're about to witness will change how you see both roads and trash forever. Southern India faces infrastructure nightmare, tropical climate year-round, heavy rainfall during two back-to-back monsoon seasons, followed immediately by scorching summer heat. This weather cycle systematically destroys roads. Soil bases get heavily eroded by monsoon runoff. Road surfaces crack and break apart from constant expansion and contraction under summer heat. Communities kept rebuilding. Same methods, same materials, same failures. Roads lasting maybe 2 years before requiring complete reconstruction. Maintenance costs consuming budgets desperately needed elsewhere. The cycle never ended. Then local engineers noticed something curious. Coconut fiber, known for tensile strength and natural decay resistance. Could this agricultural waste actually stabilize soil and prevent erosion? The idea seemed absurd, but they started testing anyway. What they discovered would revolutionize road construction. Southern India is the country's true coconut capital. Over 19 billion coconuts harvested annually, different parts used for various purposes. Coconut water bottled for drinking, white flesh processed into flour or pressed into oil, even byproducts turned into food ingredients, but husks treated as worthless waste, burned, buried, ignored. Yet these husks possessed properties that seemed almost engineered for infrastructure. That insight led to creation of coconut fiber geotextiles, breakthrough solution for building sustainable, low-cost, environmentally friendly roads. This 100% natural fabric, woven entirely from coconut fibers, locks soil in place, spreads out compressive loads, protects ground from erosion during rainy season, while still allowing water to pass through naturally, preserving soil structure and maintaining environmental balance. But first, they needed to transform trash into engineering material. That process would prove more complex than anyone anticipated. Coconuts get harvested 1 year after they first form, when husks have matured enough for fiber extraction. Skilled workers climb coconut palms reaching 10 meters tall. No ropes, no safety gear, just a machete in hand. They cut entire clusters, letting them fall freely to ground, each coconut weighing over 3 kilograms. This method isn't always safe or efficient, in difficult terrain or with palms too tall. Workers use long poles, sometimes up to 10 meters, cutting coconuts from ground. While this keeps harvesters safe, coconuts fall with force, hitting rocks or exposed roots, cracking shells, seriously affecting quality. After harvesting, coconuts get transported to collection points where dehusking begins. Coconuts split open, husks separated from shells using sharp wooden or metal spikes. A skilled worker can husk anywhere from 500 to 1,000 coconuts daily, depending on size and moisture levels. The fibrous husk makes up about 35 to 45% of total weight, and it's this layer containing valuable coir fibers. But raw husks aren't ready for roads. What happens next transforms agricultural waste into construction material. Coconut husks get loaded onto trucks, transported to nearby processing facilities, dumped into open yards for storage. Average facilities process up to 2 tons of coir daily. Husks spread out and left drying under natural sunlight for 2 to 4 weeks, depending on season. This drying stage reduces moisture from around 65% down to about 15%, softening husks, making fiber separation easier. Massive piles of dried husks get gathered by heavy loaders, scooped up, transferred into large transport bins beginning processing stage. Collected husks dump into feeding hoppers, directing them toward conveyor systems. Conveyor belts carry material into decorticating units at steady, controlled rates, ensuring continuous flow for efficient separation. Inside decorticators, rotating blades and tearing rollers break husks apart. releasing coir fibers spilling out in loose, tangled bundles. Inner pith and shell fragments get removed. Separated fibers enter rotary drum sieves, filtering out dust and fine particles, leaving only clean, long strands. But raw fiber still isn't ready. The real transformation hasn't started yet. Coir fibers get taken outdoors, spread under sun to dry for 3 to 7 days depending on weather. During this stage, moisture drops from around 15% to below 5%, stabilizing fibers. This final drying ensures coir becomes lighter, cleaner, ready for transport to weaving facilities. Then comes critical transformation. Coir fibers move to pre-twisting sections. Spinning machines run continuously, forming consistent, stable fiber bundles. Capacity up to 3 tons daily. Fibers get loosened and sorted by length, twisted into uniform strands with reliable tensile strength so they won't break or tangle during geotextile weaving process. Depending on product requirements, fibers can be refined into thinner, softer strands, matching different loom types and weaving densities. Once prepared, bundles get rolled, tied, sent to weaving areas where they transform into coir geotextile fabric, used for soil reinforcement, erosion control, natural drainage. But the weaving process itself, that's where simple fibers become engineering material capable of holding roads together. When bundles of coir fiber arrive at weaving areas, they're wound onto large spools, fed into looms beginning fabric formation. Longitudinal strands stretch tightly in parallel rows, creating warp system forming structural backbone of geotextile sheet. Next, cross strands weave through using guide needles and bars, forming strong interlocking patterns characteristic of coir geotextiles. Loom moves in steady rhythm, placing each fiber layer precisely, maintaining consistent mesh spacing, optimizing drainage and soil retention. With every pass, fabric gradually takes shape, coarse natural texture but high tensile strength, making it suitable for soil reinforcement and erosion control. Once weaving completes, rolls get inspected for uniformity, thickness, knot integrity, ensuring they meet field-grade construction standards. Finally, fabric gets rolled into large coils, ready for transport to road projects, slope stabilization sites, land restoration areas. On average, 100 kilograms of coir fiber produces around 250 to 300 square meters of geotextile fabric at 1 meter width. Costs ranging from $120 to $180 per meter, depending on thickness and weave density. But does it actually work? That's the question American engineers kept asking until they saw roads being built. Coir geotextile rolls get loaded onto trucks, transported to construction areas. Once on site, unloaded either manually or with lifting equipment, depending on roll size and length. Moving large continuous rolls helps installation run smoothly without needing multiple seams or overlaps. Road rollers compact and smooth soil surfaces, removing bumps, loose material, uneven spots along alignment. This creates firm, level bases, ensuring coir geotextile can be laid flat, without wrinkles or gaps. At work sites, rolls positioned at road starts get pulled along alignment by construction crews. Workers carefully unroll coir geotextile over leveled soil, making sure it stays straight, fully contacts ground. Workers secure fabric using stakes, pins, steel anchors, preventing shifting during next construction stages. Proper alignment and smooth, wrinkle-free surfaces ensure optimal drainage, soil retention, even load distribution. The coir geotextile helps stabilize underlying soil, holding soil particles in place, especially during heavy rain. Its natural woven structure spreads pressure, reduces localized sinking on weak or unstable ground. But laying fabric is just beginning. What comes next determines if roads actually survive monsoons. Once fabric is secured, gravel layer spreads on top, forming load-bearing surface. This helps lock geotextile in place, distributes weight evenly before soil layer gets added. Road roller follows right behind, compacting surface, creating smooth, stable base, typically about 10 to 15 centimeters thick, ensuring it becomes firm enough, supporting final road surface. This is followed by soil layer, creating uniform base while protecting geotextile from direct pressure. After that, additional layer of coarse crushed stone spreads across roadbed, increasing bearing strength, improving drainage. Road roller then compacts this layer, locking stones into place, creating firm foundation ready for final paving stage. When base is stabilized, remaining steps mirror standard asphalt road construction. Asphalt spreads evenly, compacted in multiple passes, finished to meet smoothness and density requirements. The result? Roads that look completely ordinary, but beneath the surface, coconut fibers hold everything together, more durable, less cracked, longer lifespans even in harsh climate conditions. But here's what nobody tells you. The coconut journey doesn't end with roads. What happens next proves nothing gets wasted. While husks become infrastructure, coconut water transforms into refreshing drinks. Inside processing facilities, coconuts feed into automated systems. Precise drills create small openings in hard shells, extracting liquid inside. After removal, water transfers into cooling tanks, capacities up to 1,000 liters, temperature lowered to 4 degrees, preserving nutrients. It passes through filtration systems, removing impurities, residue, oils. Finally, coconut water gets briefly sterilized, eliminating bacteria, cooled again, keeping original freshness and nutritional value intact, then moves to modern packaging lines, filled into pre-sterilized multi-layer cartons, protecting product from light and air, extending shelf life. Fully automated lines operate with high accuracy, efficiency, capacities up to 6,000 cartons hourly. Meanwhile, coconut meat takes different path. Some gets pressed, extracting precious coconut oil, rich in nutrients, nourishing hair, softening skin, supporting wellness. After being cut into small pieces, coconut meat transfers into automatic washing systems. Powerful jets of high-pressure water completely remove dirt, sand, remaining impurities. Some factories use warm water or mild disinfectant solutions for more effective cleaning. Next, coconut meat moves to grinding and pressing stage. Cleaned pieces feed into grinders, sharp blades spinning at high speed, turning them into smooth mixture. Mixture then transfers to mechanical or cold pressing machines. Strong compression separates oil from coconut fiber, preserving natural aroma, ensuring high purity level. Coconut meat also gets finely ground, producing coconut milk. Nutrient-rich plant-based milk, creamy, smooth, naturally aromatic. Grinding and extraction process carried out immediately after harvesting, retaining maximum freshness. After grinding, coconut pulp gets cooked at temperatures around 60 to 70 degrees for 30 to 45 minutes. Oil rises to surface, bacteria eliminated, serving as important step, ensuring final product quality. Once fat separated, soft velvety coconut milk transfers to fully automated packaging lines. Clean cans pass through sterilization chambers, temperatures above 120 degrees, removing all bacteria. Coconut milk carefully filled into each can, lid sealed within seconds. Process ensures safe, long-lasting, high-quality product. Single factory can process up to 2,000 cans hourly. Then, cans pass through high-pressure processing systems. Technology using extremely high pressure up to 600 megapascals, eliminating bacteria without heat. Product retains natural flavor, color, nutrients much longer than with traditional thermal sterilization. System neatly arranges cans into cartons, about 24 cans per box. Cartons sealed and labeled with barcodes, easy traceability, ready leaving factory, distributed to supermarkets and dining tables globally. Alongside coconut milk, meat continues transformation into colorful traditional sweets. White flesh sliced into thin strands, about 2 to 3 millimeters thick. After shredding, coconut rinsed with warm water, reducing oil and natural aroma. Then drained, cooked with sugar over medium heat. Process lasting 45 to 60 minutes, allowing sugar absorption without breaking strands. Finally, candied coconut dried at 60 to 70 degrees, extending shelf life while preserving softness and signature fragrance. After drying, transferred to packaging areas, evenly portioned, placed into zip bags or sealed plastic pouches. Clean, dry environment. Each bag heat sealed, labeled with weight, production date, expiration date, ensuring food safety. Indian engineers transforming 19 billion coconuts annually from agricultural waste into geotextile fabric with tensile strength rivaling synthetics, requiring zero petroleum products, producing 250 to 300 square meters from 100 kilograms, costing $120 to $180 per meter, creating roads lasting through monsoon floods and summer heat, while coconut water fills 6,000 cartons hourly, and coconut oil gets pressed, and coconut milk produces 2,000 cans hourly, and candied coconut becomes traditional sweets. Every element utilized, nothing discarded, proving solutions to infrastructure problems sometimes hide in waste streams farmers were burning. What amazed you most? The fiber strength, the complete utilization, the road durability? Drop thoughts below. Thanks for watching Macro Forge, where trash becomes triumph and waste becomes infrastructure. See you in the next one.